Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm good, thank you. How are you?
Very good, very good.
Good.
So, Amy, based on our last class, which we talked about composite functions, and we also discussed, kind of reviewed inverse of a function, because
Yeah,
sometimes we have combination of composite and reverse inverse functions in your examination style questions, right?
right.
So
Yeah.
I made some multiple choice questions so that we could quickly go through that. It will kind of give you a review of all the concepts, and if there's something not clear, we can work on that, right? That's
Perfect.
the whole
Yeah.
idea. So let me share with you today's lesson, which is kind of a mock test for you, okay?
All right.
Let's see how it goes. So there you go. So I hope you remember the very first screen, which is based on composite functions, correct?
Oh,
See that?
yes, I do. The
You
yarn.
remember? You remember
Yeah.
what is all about, correct? So, okay, let's try. So we are talking about composite functions where we are saying is that we took this example. I love this. From yarn, you make fabric, and from fabric, you make garments. That's the
Right.
normal sequence. When we say composition of functions or composite functions, it is kind of a production line where you
Right.
follow a sequence, correct? And whatever is the output of first it becomes the input of the other, the next one, and then that is followed, right? So you could have composition of many functions, not just two. So we just say two or more functions, right?
Yeah.
Interesting part here is that when we are working with yarn, we could have multicolored yarns, different types of yarns, cotton, silk, and so many other varieties, right? Endless. So that is the domain of the yarn. And from these yarns, we are making fabrics of different types of fabrics, different counts. They will have thread counts and all those. The materials may be different, but you know, different kinds of yarns will give you different kinds of fabrics. So
Yeah.
we have the whole range of that yarn. Now, this range of yarn becomes the domain for the garments, correct? Because we
Right.
have
Yeah.
now the fabric. I mean, so the range of yarn is the fabric. So this fabric becomes the input for the garments or the domain for the garments. Now,
Yeah. Yeah.
depending on your type of industry or the production which you want to do today, right? So let's say today we want to start with our uh, s- spring collection, for example. So you
Hmm.
need a lot of colors, and you just want to take some multicolored, bright yarns, maybe silk, right? You just take up this motif. So all the yarns which are related to that, you will take them. So that range of that fabric of that yarn will become
Hmm.
the domain for your garment. That fabric.
Right.
You choose
Yeah.
a
Yeah.
set of fabric which suffice or meets your requirements, and then you make garments out of them, right? So that is your next function. Correct. So this is how I'm saying is, so we are talking about two functions. The inside function, which is the yarn uh, to fabric, that is the first function. And then when you combine, you get the garment. So ultimately, we have connected the yarn with the garment, and that is what this composite function, G of f of y is, where y stands for the independent variable yarn, correct?
Yes.
Many
Yeah.
ways of writing this. We can write g of f of y without that of circle, right? So we could write like this. We may just write gf like this also. It means it's just a composite function where
Right.
g and f are there. Sometimes we put square brackets. We do all those things with these functions. These are normal ways, correct? So there's a quick review based on this. Now here are 40 questions for you, right? So I made 40 questions for you, but they're related. So if I take up one question, I've just made it three out of those one so that we really get the whole concept, right? So I'd like you to
Yeah.
read the screen and answer these questions one by one. So the very first question, can you read this?
Yes. So we've got f of x, and then we've got some coordinate points. So
Hmm.
0, 1, 1, 3, 2, 5, 3, 7, 4, 9, and 5, 11.
Hmm.
And then you've got g of x with another set of coordinate points with 1, 1, 2, 4, 3, 9, 4, 16, and 5, 25.
Correct.
So find g of f of 2.
Tell me the answer, which one matches and why.
Okay, so f of 2,
Hmm.
we know the output is 5. And then
Correct.
if I put 5 into g, I get 25. So the answer is 225.
Perfect. So very
So
good, very
D.
systematic. Second answer, find.
Find f of g of 2. So g of 2 is 4, the output. 4 is 9, so C.
Perfect. And the last one, question number 3.
Okay, so f cubed of 0. So f of 0 is
That is
1.
f of f, right? So we could have this
Right.
choice, one simple, right? So f of 0 is what? 0 is 1, right?
1. And
And
then f of 1 is 3. And then f of 3 is 7. So
you get
D.
the idea. So you
Oh,
could
okay.
have these kinds of combinations also. So that's something new which I wanted to introduce to you, right? Now
Yeah.
here is this second set of questions based on the same data, right? So now
Okay.
we'll find the domain of f of g of x. So how do you find domain of f of g of x? Tell me.
So,
G of
so,
f of x this time. Yeah. G of f of x. Tell me.
so the domain for f of x
Mhm.
is from 0, 1, 2, 3, 4, and 5.
Mhm.
But then the domain for G is only from 1, 2, 3, 4, and 5.
How about the composite function?
So the composite, um, uh, I know 0 won't be in it,
Zero won't be there.
but I
So
don't know
you have
how
to
to
start
question.
with f of x. So f of x 0, output is 1. Do you see that subdomain? So now 1, you have to check the value of g. You have 1. So 1 comes in your domain for sure. You see
Oh,
that? So
yes, yeah.
you're right. 0 will be the domain. That is correct. So 0 gave you some output, correct?
Yeah, yeah.
That is correct. Now, you tried with 1 and you have 3 here. Do we have 3 here? Yes. 3 gives
Yes,
us
we do.
9, correct? So it is a good idea. When we write here, let me write down the function itself so that it can answer many other questions also. With 0, you get 1 as the output, correct? And
Yeah,
with 3, what do you get as output? 3, 9 you get output. Is that clear? And with
yeah,
2, 5 square is 25. We get 2, 5, 25, correct? And
yeah.
with 3, 7, there is no 7 in
There
it.
is no 7.
So basically, what you get is 0, 1, and 2 as your output. And so the domain of this function is 0, 1, and 2, which I kind of missed here.
C. Yeah.
0, 1, and 2. Yeah, I wrote all these questions yesterday. So maybe some typing errors. Okay, very good. Now, that is the way of how you have to do it, correct?
Right, yeah.
The other function is kind of reverse. We are trying f of g of x. So you'll begin with this particular function. 1 gives you an output. So you write the
1
function
gives
itself. 1 gives you 1 and 1 gives you 3, right?
3. Yeah. So
So, and then
2
2 gives
gives
you
you
4, 4
4.
gives you
4
9.
gives you 9.
Right.
3 gives you 9, and then you don't get anything.
That is it. So those, so 1
So
and
just
2, 1
1
and
and
2 is
2.
for this. Yeah. So maybe when I was
I
copying
see.
something, I wanted to correct this one, but I deleted that also. Okay.
Oh,
So you get the idea, right? So
yes, yeah.
with the composite function, if you change the order, you get a different function altogether. Do you see that part, right?
Right, yeah.
Now, second part is to use the inverse of a function with the composite function, right? So now this question is kind of like this. To find the inverse, you really swap x and y. And can you
Yeah.
see this question? How will you solve this question? What is f of g inverse of 4? Can you tell me now?
So if you have inverse of G as 4,
Mhm.
so the output, so if it was just G of 4, the output will be 16. But because it's inverse, do you have to swap the coordinates?
Yeah, you can take this one. Do you understand? So the for the
Oh,
function, the output was 4. You have to look for that input because when you swap, that input becomes the output. So 2. So basically, at this stage, you're looking for f
oh,
of 2. You get the idea.
yeah, yeah.
And f of 2 is 5. And
5.
that is your answer. You get
So
the
because it was the input there, you have to look for the output there.
yes.
Yeah.
So that is how.
Oh.
Do you see
Did they
that?
do questions with inverse composite
No,
function? They
we
don't.
didn't do. We didn't do. So I have introduced some here.
Ah,
This is what you might get
nice.
in your test, right? You get
Yeah, yeah.
it? So very
Makes you
interesting.
think.
Yeah, so again, we have this combination. Now I'm going to inverse of inverse. Now answer this one.
Okay, so so because we're putting 4 in, it has to be the output. So again, it will be 2, 4. But f of inverse 2, so because that's the input, we need to look for the output as 2, which it doesn't exist.
You get the idea. It doesn't exist.
Oh, okay, I like that. Yeah,
So
that's good.
don't do flukes, right? You have to go properly and see
Yeah,
what is
yeah.
happening here. So practice one more because this is new to us, right? So f
Right.
inverse of 5 is what?
Okay, so we are trying to look for the output as 5 for F, and that says 2. Then we put the input G of 2, which is 4. So B.
So while making the questions, I did minimum typing, to be very frank with you. So I kept into mind that this is my set of answers and I revolved around those answers.
Oh, I see. Yeah.
Just use the
That's
same.
really helpful, though. Yeah,
Yeah,
I
it
like
gives you
that.
an idea. How do we look into it?
Yeah, definitely.
Different ways, right? So more of this you can try later. I'll upload this, right? And then you
All
can look
right, okay.
into it. Okay.
Yeah, I'd love to.
Yeah. Okay. Question number 10 is combination of functions. Now, when we say composition, there's another word which says combination. Combination not is not really composition. It is like adding and subtracting. It's a different operation, right?
Oh,
You're
oh,
not
right.
changing a
Okay.
function. You're not changing any function, right? You're just combining the two, adding or subtracting.
Yeah.
So that is combination. And that's why we have an example here, just to give you an idea that combination is a different story altogether, right? So what is
Okay.
g of 1 plus f of 1? Can we answer this quickly?
So G of 1 is 1, and F of 1 is 3. 1
It's
plus 3
simple
is
math,
4.
right? See, we got this 4 answer again. Okay, that's very good. Okay, now let's get into the functions. We were working with the coordinate points so far. So if you have a function, have seen examination type questions involve quadratic functions with the linear. That is most of the time seen. And therefore,
Right.
again, this example, x square minus 4, and we have restricted the domain. See, we are only taking the one portion of the domain, which is x greater than equal to 0, right? That means
Yeah.
the right half of this parabola. We're only talking about the right half of the parabola. However, as far as the line is concerned, we are talking about the whole line, right? So those are the two
Yeah.
combinations. So we do have restriction on one of the functions, and that's parabola has restriction now on both domain and range. Remember that part, correct?
Yeah.
Now, can you, first question, very simple. Find g of f of 1. So what will that be?
So F of 1 we can do because it's in within the domain.
It's like
So F
1
of
minus.
1 is 1 minus 4 is minus 3, and then G of minus 3 is minus 2. Minus 3 plus 1, minus 2.
Got it.
See?
So
Okay.
now we'll do the reverse calculation. We are not saying that g of f of x is 1. You have to find x. How will you do this question?
So I just find the formula. So basically, I sub in x squared minus 4 into the g of x. So x squared minus 4 plus 1 equals
Okay,
1.
you'll find the combination of the function. That's what you're trying to say. You will
Yes.
say, well, this is x plus 1. So instead of x, you write x squared minus 4 plus 1, right? This is your
Yeah.
combination, correct? And that is given you x squared minus 3, correct?
Minus 3
And then
equals 1.
equals 1, and then you'll solve it. You'll say x square equals to 4, and then x is equals to square root of 4, right? Which
Plus
is
or
plus and
minus 2.
minus, which is plus and minus 2. However, we gave a restriction. Do you see that?
Right.
So you have to
So,
remember the restriction was there, so we'll take only the positive 2 part, and though the answer will be D, not plus and minus 2. You get the
yeah.
idea?
So
So
can I do it like that, but then just remember the restriction, or do I have to do something before to avoid that mistake of forgetting?
first thing first. So whenever you have the function, you have to make a note that there is
Oh,
a restriction on both domain and range. And therefore,
okay.
when you write the answer, you have to look back and see. Does it make sense to you? You get the idea?
Yeah,
You have to
yeah.
do that, right? So you could definitely answer the question as you did. Now, let me tell you, how do we answer this multiple choice question without doing all this?
Oh.
Is that interesting?
Yes, because I want to know a shortcut. Who doesn't want to know a shortcut?
Okay. So we are saying that the output of g of something should be 1. That means x has to be 0. Do you see that? Only then I will get output of 1.
Oh, yeah.
If x is 0, so that means you get my point. That means I'm actually looking into g of 0, right? That is going to give me 1. Is that okay?
Yeah, yeah.
Right? So that means f of x is 0, right? That means that x squared minus 4 is
Minus
0. Do you see that? So I did not do all this, but I got the same result.
Oh, Yeah. Because whatever value f of x is, you're putting it into G, and it has to be 0 if you want to get 1 as the output.
And it does say that x is greater than equal to 0. I'm just stating
Mm.
this statement. So I'm not missing that idea at all, right? So I know it's
Yeah.
positive. So x is equal to square root of 4, which is equals to 2. And there you go.
Oh
You
my
just,
God.
so this is not
That's
the
so
answer.
crazy.
This is-
Yeah,
So
yeah.
we'll actually do the reverse calculation just as I have shown you, and that's the way to answer a multiple choice question. This is not, I should say, not, I'm not wrong, but not the best way of doing it.
Yeah, it's not the most efficient way.
You get the idea? So
Yeah.
we work whenever it is to, we have given the function, the output, find the value of x, just move in this way as I showed you. Is it
Oh,
clear to
right.
you? Yeah, look at
Yeah,
this.
yeah.
Now, next question is kind of simpler. So f this time, yeah, this is interesting again. F inverse of 5 and then the g of that. So how will you do this?
Uh, See, I was gonna say I need to find the inverse of the f, but
No, no,
that's too
no,
long.
no, no,
I know,
no.
so I'm trying to work with what you're saying. So
Yeah,
wait. So if I put 5 into the f of x,
great job. Dan. You got the idea. You got the idea. Put 5
yeah,
here. So 5 is equals to x square minus 4. But is 9 equals to x square. So x is equals to 3. You got this, right? And
yeah,
g of
and then
3
I
is
put
3
that into
plus
3.
1, which is 4. Correct? We got this answer. Do you see without doing the inverse, we got the answer?
Mm,
Do you like that?
yeah.
That is what you do. The question is not asking you to find the inverse. It is not real question which you get first part A, find the inverse, find this, and then this. No, no, no. It is a multiple choice question. Everything included. So now use reverse calculation and your techniques, which you have learned.
So
Yeah.
is it because if it was just f of without the inverse, if it was just f of 5,
Then it was
5 would usually be our input, but because
yeah,
it's
yeah.
inverse, we're making as the output.
Output. The
So
simple
we're making the x squared minus 4 equal 5.
perfect. You get the
Uh,
idea.
yeah. See, I was trying to say what I would have done and then what I should do.
I love
Okay.
that. So because you're my
Okay.
student, you understand that we could do it in so many ways, but we should always use
Always
the
I'm
most
wrong. Yeah.
efficient way, right? Most efficient way. Yep.
Your way is the most efficient.
Time is very critical. Perfect. So I think you got a good clue on when you have inverse involved with composite, it becomes tricky. But the thing is, we have to see from the reverse direction, it becomes simpler, right? Okay.
Right.
Well, this is very similar to the example which we did. When I upload, you can look into this, right? Or maybe something new is to find range and domain in this particular case. I'll leave that for you, okay?
Okay.
I'll leave that for you. So you should work on this. And this is again a similar function. So the next three set of questions on combination of a parabola and this is square root. So let's look into the square root function now, okay? Question number
Okay.
20. Can you please read this and let me see?
Yeah. So f of x equals 3x minus 12 and g of x equals square root x.
Yeah.
Find the x-intercept of the function f of g of x.
X into, now tell me how will you do?
Okay. So we're trying to find the x-intercept. It would help me if I did a quick sketch. Okay.
Okay. Oh, but there is
So,
no. Sketch will not help you. I'm just making sketch only to understand what is
mm,
x-intercept. X-intercept is a point where the y value is
y
zero. Is
is
that clear?
0. Yeah.
When I say find x-intercept of this function, right? It really means that the y value, the output is 0. Is that clear?
Mm, yeah.
Output 0 means outside function is f should be 0. So this should be 0, right? So this should be 0, correct? So we have 3x minus 12 equals to 0. So that means x is equals to 12 over 3, which is 4. So that means g of x is 4, correct? And g of x is square root of x, correct? So square root of x is 4, and therefore x is equals to 4 square, which is 16. So
Hmm.
let's see again what happened. So if I plug it back, if I write 16 here, for example, let's just check it. So if I write 16 for g of x, so f of, let me write down 16. So it's square root of 16, right? Which will be f of 4, correct? So if I substitute 4 here, so what do I get? F of 4 is
0.
12 minus 12 is 0, right? So that is the correct answer. This should have been 16. Is that clear to you?
Yeah. But yeah,
You
the
see
only
how?
way I would have approached that was by putting and making a formula, but that
No.
would have been too long.
Well, not very long. In this particular case, it is not wrong. Let me just show you. Let me just show you, right? So let me erase
Because
this.
it's hard to get my head around that. Like, I understand that the output should be 0, but why is the 3x minus 12 0? Why is it not?
Okay, I'll explain you that then. In that case, yeah, this is kind of critical, right? This is a simple function, and therefore, some students might think, why all this, right? F of g of x square root simple function. So I would write f of g of x is really equal to 3 square root of x minus 12. Is that clear?
Yeah,
Okay.
because you just
And
substitute.
if we want find x-intercept of this particular function, that means the y value is 0. So I
Yeah,
get 3
and
square
so
root of x equals to 12,
12,
and square root of x is equals to 12 by 3, which is 4, right? And so x is equals to 16. Clear, right?
16. Yeah,
So I typed it wrong. This should have been 16. And that's how you will get the answer. So this particular case, it was very simple to write this. Correct.
okay.
I agree with you. However, let us also see the reverse calculation. This could have been very complicated. This could have been very complicated. So
Yeah, yeah.
in that case, how will you answer, right? So we want x-intercept. X-intercept is the output, correct? So we are saying that f of g of x is equal to 0. Is that okay?
Yeah.
That is what we are saying. So function, so what should be this value of g of x? So what is g of x equal to, which will make f of that value of x as 0? So that means g of x, this should become 0. Is that okay? So whatever the x value
But,
comes out of g of x,
oh,
that should
yeah,
f
yeah,
of f that should become 0. Do you get the idea?
yeah, yeah,
So this becomes 0 for x equals to 4, correct? So that means the output of g of x should be 4.
yeah,
So therefore, I said square root of x equals to 4, and then
right.
figure it out. But it's kind of tricky to think like this, but it's a good time to
Yeah,
exercise your mind and do this reverse calculation. This is an exercise to do
yeah,
the reverse calculation. Okay. Uh,
yeah,
so no harm in doing direct, because most of your questions are not that complicated. They will be as simple as I have given you on the screen. So you could write the composite function and get the solution. No problems, correct? Now, what is the domain of g of f of x? What could be the answer? So let's write down the function. What is the domain of g of f of x? You'll say g of f of x will be what? Square root, g is, and x is all this, correct?
yeah.
So that is simple, and you can tell what the domain is. 3x minus 12 should be greater than equal to 0. 3x should be greater than equal to 12. X should be greater
X
than
is
equal to.
going to 4.
So you got the domain. Is that clear? So
Yes.
similarly, we could find the, now this is just getting the function, correct? So find the function. We already know what the function is. We have worked out g of x is given to us, and now f of x. So what is the function? This is the very first function which we did, correct?
Yeah.
3 times x times we could do it, correct? Yeah. So that part is very clear. I have taken this up exponential function, which is again a slightly challenging topic for you, since we have not done really at length
Is.
exponential
Yeah.
function. But anyway, we have some idea about it. You learned about it in year 12, correct?
Right.
So f of x is e to the power of x and g of x is ln x. Find the function f of g of x. Tell me this function, f of g of x.
Okay. So is it is it C?
Okay, you wrote C. Let me work it out. So f of ln x and e
Because
to, which is
e to
e to
the
the power
ln
of
x
ln x is
is
equal to x.
x.
Yeah. And why did you tell me C?
Because e to the x is the domain is x where it's greater than 0 because it never touches the asymptote, the x-axis.
Perfect. Perfect. So you got the right answer. Let's do it again for question number 24. This time it is f of g of x, f of g of e. You can now plug it in e and you get your answer as e, right? So the answer will be e for it. That's okay. Question number 25. We have reversed the function. It is now g of f of x. Can you tell me what will this function be? G of f of x. So basically we have uh, g of f of x is e to the power of x, and
So
then that will give me
ln e to the x
ln e to the power of x, and that is
is
going to give me ex, right? Again, x. So
x.
which one
Yeah.
is the right answer?
Wait, so it's not, I know it's not going to be the same thing as before. Or is it? Yeah, I'm trying the domain. I feel like it's just all real numbers.
You're right. There's no restriction in the domain this time. Earlier, there was a restriction. Do you note that part?
Yeah.
Because e to the power of x is always positive, right? So e to the power of x is always positive, and therefore ln, you need a positive number, so it gets a positive,
Yeah.
right?
Yeah.
So there is no restriction in this particular case. So that makes it very interesting. You get the idea, correct?
Yeah. Yeah.
So the rest of the questions I'll just share with you. So it is more extension to the
Ah,
logarithmic and exponential functions. This time I kind of complicated the two things, right? But it's kind of similar. I would like you to answer these questions, right? So I'm just leaving them for now. Look
okay.
into them, and now these are slightly more difficult, also, correct? But
Yeah, I can
you
see.
apply alternate ways of answering the question. Is that clear to you?
Yeah.
So
Yeah.
do it algebraically as you should do in the test paper, because your test papers do not have multiple choice.
No.
But on the other hand, practice. How do we get it around? Do without algebra, kind of, and
Yeah.
get,
Yeah. Like your output method and like thinking in a reverse order,
because
which is
that is,
tricky, but it's helpful.
because that is the concept. Coming back to our concept, what we said is, that is what we have. This
Inside
is
out.
composite function, correct? We are going from here to there, and we are only selecting a part of it, and then that part goes into this, and that
Right.
becomes our range. So always we are looking into the small, small parts. Do you see that?
Yeah.
So
Yeah.
that's very important.
So
So
substance.
subtext. So if you keep this picture in your mind with the yarn example, garments, we wear
Yeah.
in.
Yeah.
Oh, that is very similar to what we just went around earlier also,
Oh,
correct?
right. The piecewise function.
Piecewise functions, you could go through that. So that brings you to the next set of questions. And now, combining square root with the square function, quadratic function, they are also very
Yeah.
interesting part. And I've used transformation in this set now, given you another kind of thing. Some transformations will be used in this, answering these questions, right?
Mm.
Okay, and that is the rational functions. So rational functions are very tricky to work with, and as we introduced to you those top concepts of function of a function, this is actually a very,
Right.
very good function. 1 over x plus 1. So when you find function of this function, you actually get to a general formula. So let me give you the general formula here. You have to figure this out while going through these three questions, correct?
Okay.
Right. So here we have find f of 4n. So you write down the general formula of f of n x. Is that okay?
Yeah.
So that is the formula which you have to figure out. Once you do these questions, you'll get the formulas. But that is very interesting formula. Okay.
Also, yeah. So am I literally taking each like 1 over x plus 1 and literally subbing it in
Yeah, yeah, yeah. And then working
3
with those
times?
fractions.
Oh,
Three times means, yeah, and keep doing it. So
yeah.
the pattern, from the pattern you can really see what the result is, right? So for
Okay.
example, in the very first case, when you do it first time, f of f, that means, then you will get a result which will be kind of like x plus 1 will go on the top, for example, right? So when you do the next time, then
Yeah.
it'll be 2 over 3, for example, like something like this, right? So when you do n time, then be x plus n minus 1 over x plus n.
Oh, I see.
So
Yeah.
something like this you're going to get as your result. So try to see from the pattern, how do we get this result? Is that clear to you? So that
Yes.
could
Yeah.
be a very tricky questions in your competitive exam. I'm just talking about your senior UK mathematics.
Challenge.
Yes,
Yeah.
correct. So there, this question could come. Well, this is again a combination of quadratic and linear, but we are talking about, in this case, more about intercepts, x and y intercepts. So directly, they don't give you the value, what you have to find. Yeah? They're not
I
saying this
see.
function is equal to
Yeah.
what are the intercepts of the function. So this is the end of my set of 40 questions for you. So try to go through them and answer. If there is any difficulty, we can look into that, right? How do you find
Yeah.
this exercise?
Really helpful. Oh my God. Like, I've never seen these types of questions. Obviously, in my book, they kind of get a bit repetitive and boring after a bit
Yeah,
because I
yeah.
just know like what they're expecting. But those ones I was not expecting. Like literally like inverse composite functions, and then just thinking of it like you said in that logical way, instead of like, imagine me subbing everything in, that's really long. But
Yeah.
this that method of just thinking it as the output and then putting it as the input is just so
Very,
helpful.
very.
So I'm going to think it like that now, in that
And
manner.
yeah, purposely, I have taken different types of functions which you will
Yeah.
come across in the test. And then with each type of function, I've taken three sets of questions so that you can see it from different angles. You understand?
Right. Yeah.
Evaluating the value directly, doing the reverse calculation, combining with the inverse function. And that is how you,
Yeah.
when you read your book now, add this question, just add your part E to it, saying f of g inverse x. And then
Yeah. Yeah.
that
Yeah.
will help you actually, right?
Just to know that that could also be a possibility of a question.
Yes.
Yeah, I like that. Thank you so much, sir. That was really helpful, like incredibly helpful. Yeah.
Thank you then. All the best. Keep
All
sharing.
right. Thank you, sir. See ya.
See you. Bye.
Bye.